My name is Yang, and today we have a webinar on how to enforce egress control in Kubernetes and OpenShift to prevent unauthorized external connections. Today, our presenter will be Glen Kosaka, Vice President of Product Management, and one of our very own software engineer, Selvam Thangaraj, who will present 3 demos and discuss several ways to enforce egress controls using open source tools such as Kubernetes, network policy, OpenShift, as well as NewVector. We also have invited our CTO and co-founder, Gary Duan, to answer any questions at the end of the presentation. So if you have any questions, please feel free to write them in the chat box, and we will address them during Q&A. Okay, Glenn, do you want to take it from here?
All right, thank you, Young, and thank you everyone for joining us today. Let's take a big picture view of security issues for containers and cloud-native deployments. Ideally, security should be built into your pipeline at the very beginning of the pipeline. So the top issues for customers in terms of container security are, first and foremost, how to detect and prevent vulnerabilities from being exploited and entering the pipeline. Secondly, misconfiguration of registries, Kubernetes, or the hosts themselves can offer an attack surface or an entry point for hackers. The DevOps team does not want to slow this modern automated pipeline. So you can't have situations where, in the case of network rules and a new application that's being deployed, they have to request that from the network team, the firewall team, and it's going to take a couple days to respond to that. Everything needs to be as automated as possible. Once containers and the infrastructure are deployed into the production environment, there are not only risks to the applications that can be hacked, but also there's a new attack surface. And that includes things like the Kubernetes API server or the orchestrator itself, perhaps even the Docker runtime. And if you're using a service mesh, even the Istio control or data plane can be a source of an attack. Now, on top of that, we have all of the traditional attacks against applications, just like we did without containers or before containers. Could be vulnerability exploits, zero-day attacks, insider attacks, ransomware attacks like we saw with Garmin recently, or even crypto mining, just using your resources. So those are all serious things to think about. Now, today we're going to focus on one aspect of security, and it's really this connection that you see between one of these container workloads to outside of the cluster, which is the cloud or another virtual machine application running outside the cluster. So let's talk about what is egress control. So for today's purpose, we're talking about connections that go outside of the Kubernetes cluster or outside of the container environment. Keep in mind that in Kubernetes terminology, egress is defined as outside of a namespace. So it could be either going outside the cluster or just outside of the namespace to another container running within the cluster. And OpenShift can define it as outside of the project as well. Now, connections outside of the cluster are required often for container deployments. Obviously, for connections to the internet that are required. It could be API services running on the internet, or it could just be to popular domains, or it could be update services. But it doesn't have to be the internet. It could be just outside the cluster, a database or another application that hasn't been containerized, running on a network segment outside and just running on a virtual machine. The reason that egress control is so critical for containerized environments is to limit the potential attacks. And egress connections are probably the most critical because that's where people can actually steal your data. So being able to control that and monitor that is so critical. In order to steal your data or install malware, there often are connections to command and control servers required going egress, or reverse shells that open up. And then in order to leverage crypto mining, egress connections are also required. Now, the reason egress control is a tougher issue with containerized environments, especially in Kubernetes, is because the source IPs of the pods can change dynamically. So Kubernetes can spin up pods, take them down, move them from host or node to node, and it makes it difficult for traditional firewalls or gateways that are really looking for the source IPs of these pods to base their policy on. That can break traditional gateways or just make it difficult. And also, if you're trying to funnel all your traffic through a gateway inside the cluster in order to egress, that can also become a bottleneck. So there's potential performance issues, or it can obscure the source and the context of the requesting service. For example, the certain service that's allowed to egress coming from a certain pod, and that pod has to be identified by labels or service names instead of IP addresses. So let's first take a look at some of the most basic egress controls built into Kubernetes, and give a quick overview of that and then a demo. So in Kubernetes, first of all, you must be using a CNI network plugin, which supports the enforcement of network policy in general. So that's network policy, just interpod, as well as egress control. And the default is that all pods can egress the cluster, but once you put in a single network policy, then once you implement a network policy, then that starts to enforce egress control in Kubernetes. And in Kubernetes, you can create egress control rules based upon destination IP addresses and ports, or you can just block all egress controls. And as I mentioned, egress in a Kubernetes context is really egress from a namespace and going outside of a namespace. So it's a namespace-based policy. So with that, I'm going to turn it over to Selvam to do a quick demo of how to do egress control in Kubernetes.
Hi, everyone. Welcome to the demo. This part of the demo, I'm going to show you how network policy can be used in Kubernetes for controlling traffic. By default, Kubernetes allows traffic within the cluster and allows the traffic to the external. Once you start applying the network policy, it's going to allow a traffic policy mentioned in the policy, and it's going to deny all other traffics. So for that, I'm going to show you. I'm going to use a network policy here. I'm going to cat that policy here. Let me walk through the policy. Network policy is based on the namespace. It's going to apply to the namespace. So here in this policy, I'm going to apply the network policy on demo namespace. And the specification section, we specify the pod selector. This policy, what pods need to be selected. Here, matching label, I have empty string, so it's going to match all the pods in the demo namespace. And the next section is policy type. It has egress and ingress. So this policy applies to both the egress and ingress. Egress means traffic going out of the pod, and ingress is traffic coming into the pod. And the next section is egress, which controls the traffic from which pod can come to the demo pod. And also you can choose what pods can send the traffic to these demo pods. Here the matching label is empty, so it's going to match all the pods. Same as namespace. Here the namespace is empty, so it's going to match all the namespace. can send the traffic to demo pods. And next section is Ingress, which allows traffic from which pods to demo pods. And also in pod selectors, it is empty, so it's gonna allow traffic from any pods to demo pods. And the namespace selector also empty, so it's gonna allow traffic from any namespace. So I'm gonna apply this policy. Before that, I'm gonna list the network policies here. So we don't have any network policy. So I'm going to apply this policy. For that, I'm using a kube control command. Getting applied. I'm going to list again. Okay. For this demo, I'm going to use parts in the demo namespace. We have few parts in demo namespace. I'm going to use ngx parts to send the traffic from, and we have a few more parts on default namespace. To demonstrate the traffic, I'm going to send the traffic from ngx parts to Alpine part. For that, I have few scripts here. So I'm going to use a curl Alpine HTTP script. Okay. You see, we are accessing ngx pod and sending traffic to Alpine using a curl command. This is successful. And to demonstrate the external traffic, I'm going to use a curl Google script. If I execute, it should be blocked. So the traffic is getting blocked. So it allows only the traffic within the cluster, and all other traffic is getting blocked. So I have one more policy here. I'm going to cat that policy. This policy also applied to demo namespace, and it has a policy type as egress, and it is allowing two subnets. I have given in IP block, and these two subnets belongs to Google domain, public domain. So I'm going to apply this policy using kube control command. I'm listing again, it got applied. Yeah, there are two policies are there. I'm going to try to access a Google again using the same script. Okay, you see, we are able to access a Google domain. If you scroll up and see that the beginning of the command, you can see the Google domain is got resolved into this IP address. Fortunately, this IP address fall into the subnets we mentioned in the policy. So we are able to access Google now. If it is resolved to different IP address, it might be blocked. So this is one of the limitation in the Kubernetes. You cannot apply the policy based on domain namespace.
All right, great. Thank you, Selvam. All right, so that's a very simple example of creating egress control policies within Kubernetes. Now, before we go on to talk about OpenShift, let's just summarize some of the limitations of Kubernetes egress control. So first of all, you can allow specific egress, but there's no concept of a deny access to specific. So allow everything except to Google, for example. There's no concept of external outside of the cluster. So as you saw, you have to specifically allow connections within the namespace or outside of the namespace, but then separately to external services like Google. There's no concept of rule prioritization or order. So, and those of you who are familiar with firewall rules know that rule order is very critical in terms of which order the connections are going to hit those rules. So that can be a little bit cumbersome. And then finally, as Selvam showed, there's no host name or DNS name support. So now in Red Hat OpenShift, OpenShift extends the capabilities of Kubernetes and adds some additional functions and flexibility. The way that it's done in OpenShift is there is a custom resource definition, or CRD, that's by default enabled on OpenShift, and it's called the Egress network policy custom resource. So the Egress network policy is able to deploy a what they call an egress firewall, and this does have the concept of egress outside of the OpenShift cluster. Excuse me. And then to define the policy, OpenShift supports one egress network policy per namespace, and not allowed on the default namespace. So all of your rules need to be put into a specific namespace egress policy. It does support the resolution of DNS names. There is a concept of rule ordering. It's a little bit limited in that the order has to appear as shown here on the right, where the different rules are shown, for example, for egress, and they're going to be executed and hit in the order that they're shown in this specific namespace egress policy. It does support deny rules as well as allow rules and ports as well. So let's take a look from Selvam about how to do egress control in OpenShift.
This part of the demo, I'm going to use egress network policy on OpenShift container platform. I'm going to use OpenShift container cluster here. I have a few parts in demo namespace. I'm going to use those parts for this demo. Yeah, it is a little slow. Oh, yeah, it's listed. It shows a few parts here. I'm going to use ngx part for this demo. Before that, I'm going to clear all my previous configurations. Cleared it. I have for this demo, I'm going to show two egress network policy, and let me cat a first one. It's a allow policy. Same as a Kubernetes, OpenShift also by default allows traffic within the cluster as well as to external to the cluster. And let me go through these policy one by one. It is also based on the namespace. We apply the policy on demo namespace here. And in specification section, we have a egress. We can have a multiple rules each policy. So the rule priority goes from the top to bottom, as Glen mentioned. And the first rule is we allowing sending a traffic to some IP address. And next three rules, we allow a few domains to send the traffic to few domains. And when you look at the last rule, which is type as a deny, so we denying all other traffic by specifying the IP address 0.0. So I'm going to apply this policy using a OSHI command. It's getting applied. Okay, we'll have to. It got applied. I'm going to list egress network policy. Okay, we got a 1. For demonstrating the traffic, I'm going to use ngx bar. I'm going to send the traffic from ngx bar to external. So for that, I have few scripts here. First script I'm going to use trying to access CNN. So we are able to access CNN because the CNN is allowed in the policy. And I have one more script to demonstrate how the traffic is denied. I'm going to use send the traffic to IBM. Okay, IBM is blocked. I have one more rule here, which specifically denies some domain. I'm going to cat that rule. Yeah. In the rules, we have only two rules, and the first rule is allows traffic to IP address. Second rule is denying Facebook. It doesn't have an implicit deny, so it's not going to block other traffic. OpenShift supports only one policy per namespace. To apply this name rule, I need to delete the other rule. So I'm going to delete the other rule. If you have a multiple policy, the egress control might break. I'm going to list it. So we don't have policy. I'm going to apply this policy using. I'm going to list. Yeah, I have one rule here. I'm going to use traffic. I'm going to use a script to send the traffic to Facebook first. Facebook is getting blocked. I'm going to use another script to send the traffic to IBM. IBM is allowed because we don't have an implicit deny rule, so IBM is allowed, even though we haven't mentioned in the policy. Okay. With this, we come to end of this demo. I'll pass the control to Glen.
All right, so there you see more flexible egress controls that you can implement in Red Hat OpenShift. Now, there are still a few limitations in OpenShift. First of all, the egress control does not apply to routes. So if you're using routes to send traffic from a namespace or outside a pod through the router, then egress controls are not going to apply to routes. Secondly, the egress control rules that you saw there apply to a namespace. So you can select the namespace from which those egresses are allowed. And unlike Kubernetes, there weren't any pod selectors specified there. So interestingly, in Kubernetes, you can do namespace and pod selectors. In OpenShift, you can do namespace, but without pod selectors. Now, in both Kubernetes and OpenShift, there's no ability to verify the application protocol being used for the egress. That's an additional level of security that can really prevent tunneling or other types of attacks that could occur. So the ability to verify an application protocol is being used for egress like MySQL or MongoDB or gRPC or even just plain SSL is not supported. And you saw the rule management capabilities of OpenShift have to be in the order that they're specified in that YAML file. All right, now we're also going to talk a little bit about egress control in Istio or service mesh. Many of you have investigated using a service mesh. And if you're familiar with the architecture, a service mesh will place a sidecar proxy into the pod for every application workload, and the connections will go through that sidecar proxy. So that sidecar proxy is a way that egress control can be implemented in a service mesh. So in Istio, the mesh egress through a sidecar proxy for DNS lookups, as well as HTTP and HTTPS traffic is allowed. And so you could see the mesh outbound traffic policy. By default, it's going to allow all egress, but you can also set it to registry only or for specific protocols or host destinations as well. You can also bypass the Istio proxy for specific IP ranges. So if you want to go to an IP address that is directly and not even go through out through the proxy, you can egress that way. Now, an alternative way of implementing egress control in Istio is an egress gateway. And so you can create and funnel all your traffic through an Istio egress gateway, which is a resource that's supported. Now, the limitations of service mesh and the various ways of implementing this are first, this is from the Istio documentation. So a sidecar proxy is not considered secure and can be bypassed. So whether it's bypassing for specific IP ranges or malicious bypass of the proxy, Istio can't guarantee that it's going through the proxy. As we said before, there's other than HTTP, HTTPS, there's no application protocol verification. And if you're thinking about the egress gateway approach and funneling traffic through the gateway, this again is from the documentation that Istio cannot securely enforce all egress traffic goes through the egress gateway. So you really, if you want to have a really locked down environment, you're going to have to use a combination of perhaps an Istio gateway policy, as well as some basic Kubernetes network policies like the ones that Selvam showed earlier, combine together to make sure and force all traffic going through the gateway and denying all other egress traffic. So it's more prone to misconfiguration and error or potential unknown holes that allow egress and you not being aware of any egress. And finally, think about the performance considerations of a sidecar in every pod, enforcing egress, or funneling all the traffic through the gateway. Those are some performance considerations as well. So let's talk about how egress control can be done more flexibly and more fully featured. So ideally, to support the most use cases you might have and the most defense in depth for egress connections, you'll want to be able to support not just HTTP, HTTPS, but multiple protocols, just raw TCP port, as you saw, but UDP connections, ICMP, DNS, because there could be DNS tunneling as well. Host name as well, as in addition to IP ranges or subnets, making it more flexible. Being able to verify the application protocol like we talked about is an additional layer of security to make sure there's not an attack built in to those other protocols, lower level protocols. Being able to also do deep packet inspections so that you can extend egress control to interesting use cases, such as going through a proxy, which is something we'll talk about in a minute. Now, one of the biggest issues with the previous approaches that we talked about is they're not really designed as security tools. So all of the monitoring, logging, alerting to SIM systems, packet captures, the ability to capture the source destination, the resolved IP, the timestamp alert, as well as to operate in different modes where some connections and egress violations could be allowed but logged and alerted, whereas other ones are actually blocked by dropping the connection. Those are all more advanced functions that ideally you'd want to put in place. And finally, a more comprehensive rule management interface supported by both a console and APIs, just like you might implement in a typical layer 7 firewall, should be used, because it is possible to have conflicts between your rules, and to be able to see them and order them properly is going to make it easy. Also, being able to monitor all of your network connections can help not just in security, but help you debug your applications. So if your application is not working, you can figure out which rules are being hit and potentially blocking the connections between your applications. So before I dive into egress control in NeuVector, let me talk a little bit about the big picture and the full lifecycle security that NeuVector provides, so that you can get some context. So at a high level, NeuVector is going to provide container security that can be automated into your entire lifecycle. So it starts with vulnerability scanning in the build phase, moves to registries, CIS benchmarks, compliance checks, and then all the way into runtime or production environments with runtime vulnerability and compliance scanning. And then in addition to that, there is runtime protection provided. And what we're going to focus on today is the container, layer 7 container firewall aspect of NeuVector and how we can implement egress control with that. But we also support the ability to inspect the container and the host for process and file security to block unauthorized process and file activity. And in order to prevent unauthorized containers from being deployed, there are admission controls. The way NeuVector works is there's a behavioral learning capability that can learn all of the network connections and container behavior, and then can create the firewall rules, and it essentially suggests those for you. And that can also be exported as security as code. So that's a quick overview, and feel free to contact us for more details on any of that. So in NeuVector, you can do egress control in really the most flexible way to support your use cases. So that's based on IP address or subnet destinations for applications just running on VMs outside the cluster, or DNS names that can be resolved. Application protocol verification for all the popular Docker applications, as well as other protocols like gRPC and SSL, supporting UDP, ICMP, DNS as well. You can base your egress control rules and really any network rules, not just on IP addresses or target host names, but also the container service or deployment names, labels, or other arbitrary groups, including groups of namespaces. A label is an important one. If you want to label your containers as you deploy them to allow egress to specific external services, you can use labels, and then NeuVector will implement rules according to the labels you have set. And because we're doing deep packet inspection, we can inspect the header as well as the network payload, and that's extensible for egress control with the DLP capability. So a couple examples of egress control in NeuVector, the very simple one, which Selvam was showing, direct connection of a pod or a specific pod selector to morningstar.com, but then blocking oracle.com. A little bit more complex example that would require some HTTP header inspection is where you may have implemented a proxy, like a squid proxy, and you're going to funnel all your traffic through that proxy, but you want the proxy and the security solution to be smart enough to allow certain connections through the proxy, but block other ones based upon certain domain names. A third one is a solution to the more of the traditional egress firewall or gateway that I talked about initially, which is if you've got fixed IP addresses that a traditional firewall is looking for, but you still want to enforce strict security requirements for access to legacy applications. How can you do that? Because the IP addresses of the containers in the cloud on the left are always changing. So if I want to enable the red service, container service, to go through the firewall and connect to the red API service on the right, but the green service should be only allowed to connect to the green service, but be blocked from accessing the red service. How do I implement those types of rules? And those are all things that can be done through NeuVector. So I'm going to turn it over to Selvam for the last demo of how this can be done in NeuVector.
In this demo, I'm going to show you how NeuVector can be used for controlling egress traffic. I'm going to start from the terminal screen. For this demo, I'm going to use a Kubernetes cluster platform. I have deployed a NeuVector cluster component in NeuVector namespace. I'm going to show you the parts running in the NeuVector namespace. For that, I'm using a kube control command. Space. Yeah, we have here it few parts you can see it. Controller pod, enforcer, and manager. These are the parts going to control the traffic. And I'm switching back to browser. Here I'm showing a NeuVector web UI. I'm going to see the groups and I'll show you here. Yeah, already it's we are on. Okay, it's not. See and group section, and you can see there are a few groups. I'm gonna search for a demo namespace. So we have a few groups here. For this demo, I'm going to use NGX group. It's a group of parts on NGX, and it's currently in a protect mode. I'm going to check a network policy available for that group, so that I'm going to filter NGX. So here it shows only one policy, which allows the traffic from NGX part to Alpine HTTP. So it doesn't allow traffic to. So I'm trying to access a few domains from NGX part. Let me try. For that, I have a few scripts here. Okay. Let me try to access the Morningstar domain. Okay, it's getting blocked. And if you look at the command here, so we are trying to access NGX part and send the traffic to Morningstar domain using curl command. And similarly, I'm going to run for Oracle domain. That is also blocked. Again, I'm switching back to NeuVector UI. I'm going to check security events. If you can see any security event for this. Yeah. I'm refreshing again. Yes, I see one event here. There are two events are there. So I'm going to click on the external IP address. It's getting resolved to Morningstar. I'm going to click again on the another one. It's getting resolved to Oracle. These two traffics are blocked and it's captured in the security event. So I'm going to allow only Morningstar. I need to create a network policy for Morningstar. For that, I'm going to policy tab. And before creating network policy, I want to show you the group we created before. There is one group called Allow Morningstar. Let me take a look at the group. Yeah, in this group, we have two category criteria. One is a Morningstar domain, other is a subdomain of Morningstar. So I'm going to create a network policy from NGX domain to this allow group. For that, I'm going to network rules and clicking in the add button. And then from section, I'm going to choose NGX group. And to section, I'm going to choose allow Morningstar. Here, I'm going to application section, I'm going to choose only SSL. Then action is allow. I'm adding it now. We need to save the policy also. Yeah. So I'm saying the policy. Okay, policy has been saved. I'm going back to terminal window. I'm trying to access Morningstar again. Morningstar is hello. I'm trying again. Oracle is still getting. I'm going to demonstrate another way of sending Oracle. If you send Oracle through proxy, this particular network policy may not be able to catch it because it's going to look for the domain. For that, I need to create one more policy here. I'm going back to UI and trying to add a policy. I'm choosing NGX and two, I'm choosing a proxy because we want to send a traffic to proxy. And in port section, I'm going to use a 3129 port because the proxy is running on the port. I have added it. I need to save also. The policy got saved. I'm going back to the terminal and I'm going to try to access Oracle using a proxy. For that, let me show the commands. What is the script? Yeah, if you look at the command, it is trying to access NGX bar, and from that, it's running a curl command using a proxy to the oracle.com. So I'm going to run that command. Oracle is able to access. So the network policy is not able to block this traffic. To block this Oracle accessing through proxy also, I'm going to use our another feature DLP. For that, I need to apply DLP sensor to the group. So I'm going back to the web UI and going to DLP sensor sections. So I have already created one DLP sensor. If you look at the pattern, you see the pattern starting with the host and space and matching Oracle domain. So I'm going to apply this DLP sensor to the group. I'm selecting the NGX part group and clicking the DLP sensor tab. And the DLP sensor is already enabled, but I need to apply the DLP sensor I have created before. So there are 3 DLP sensors there. I'm selecting the first one to block the Oracle. And if you look at the action, its action is by default is denied. So I'm applying that DLP sensor to the group. It's got applied. I need to go back to the terminal, try to access the Oracle using proxy. Okay, it got blocked. Okay, let me go back to the web UI and go to the security event section. You can see the first event is triggered by a DLP. And there is one icon you can see, show packet. I'm clicking that packet. Okay. It shows the content which triggered the DLP. If you look at the packet detail, you can see the host section here. This section is able, this part of the packet has triggered this DLP button. In turn, it got blocked. I'm going to show you one more section here. Before that, let's see whether Morningstar is able to access to the proxy. Yeah, still Morningstar is able to access through the proxy because the DLP doesn't match the Morningstar. And I'm switching back to NewVector Web UI. And I want to show you network activity graph. And in filter section, I'm going to choose the demo namespace and filter it to see only demo namespace. You can see NGX part, and there is a session to allow Morningstar group, which is one is allowed. And there is another session to proxy, which is what blocked by DLP pattern. And also there is a session from NGX part to Alpine HTTP, which was allowed within the.
All right. Thank you, Selvam. That was really awesome, showing starting from the simple use case to a much more complex use case using the deep packet inspection to detect the oracle in the host header. All right, so I've included and Selvam has helped me develop this summary comparison of the various ways of performing egress control. It is in the handouts, so you can download it or request it, and we can send it to you later. That could be helpful in evaluating your egress control. Quick note that you might have seen some credit card sensors in the DLP. So DLP can also detect credit cards or unauthorized PII data, so security numbers, that is either going external and block that, or even unauthorized connections within your cluster as well. And as I alluded to earlier, all of the policies that you saw in the console in NewVector not only can be managed through the console, but it can also be managed as code, just like you would develop and manage the Kubernetes or OpenShift YAML files. The way that workflow would work is the developer creates the application and the deployment manifest, hands it over to the test and QA team or DevOps team. And when they run that in the NewVector environment, NewVector is going to learn all the behavior and write those network rules as well as the process and file rules for you. That application security manifest can be exported and reviewed with the dev team, and then the DevOps team can check it in just like code and then deploy that into the production environment. The way that looks is like a typical YAML file, except like in the case of OpenShift, it was a CRD for egress network policy. This is for the NewVector security role, CRD. And the egress is what we've talked about today, egress connections to allow external access. We also provide ingress controls, file activity that's allowed in the containers, processes that are allowed to run in the container. So it's really a superset of both egress control and network policy. And then finally, you can run in different modes. A monitor mode would just allow those violations, but alert you, and a protect mode would actually block those, as you saw with Selvam. So we're able to really capture all of the application behavior. We're able to check it in and version it. You can do it for not just application security rules, but global security rules like no SCP or no SSH allowed into or out of containers. It supports the Kubernetes RBAC and OpenShift RBAC settings. And it's excellent for migrating your security from staging to production. And finally, you can use OPA, Open Policy Agent, to manage and query such security CRDs. All All right, so let's recap and then take any questions. So in summary, egress control is critical for preventing data breaches and attacks. There are different ways to enforce it, including open source ways with limitations. NewVector offers the most flexibility, security, monitoring, all of those capabilities. Not just that, though, but also together with east-west traffic segmentation, container process and file protections, vulnerability management, so full lifecycle. And automation is possible, so you can integrate all of that into your CI/CD workflow. So there is an automation ebook in the handouts which you can download or come to our website and get, which details how to automate all of container security into your pipeline. All right, so with that, I will ask Young if there's any questions. Do put those in the question box if you have any questions.
All right, thank you, Glen and Selvam. Let's go ahead and open up the Q&A. The first question we have is, can NewVector implement the same namespace-based rules like Kubernetes? Glen, I think this is for you.
Yeah, thanks. Yes, the answer is yes. Selvam showed really much more granular, so you can select it based on Nginx or the actual pods, even if the pods scale up to 100 pods. But you can also create a group that represents everything in the namespace. So domain equals demo, for example, and then you could easily apply a rule at the namespace level. So it is supported in that fashion.
Okay. And then, can NewVector rules be created through command line? I think this is for you, Selvam.
I can take that. Yes, apart from configuring from web UI, you can configure the NewVector from command line as well as REST API. And also, as Glen mentioned, you can use a CRD to create a policy and apply to the NewVector. Thanks.
Okay. And then a question from Sajit, who wants to answer this. Does NewVector itself run as a pod in the Kubernetes cluster?
I guess I'll take that. Yeah, I didn't talk about the architecture of the NewVector product. NewVector is a container, so you deploy and manage us just like you do any other workload. There's an enforcer which does all the egress control and packet filtering and endpoint inspection, and that's deployed as a daemon set. So in other words, one NewVector enforcer on every worker node, and if you choose to put them on the master nodes as well. So yes, it is a pod in the cluster. We also have a control plane pod that manages the enforcers.
Okay. And then if we're using an HTTPS proxy, how can it handle egress? I think this is a question for Gary.
So as Selvam in the demo, Selvam showed using the DLP to identify the patterns in the traffic. So you can see not only we can match the pattern, but also we can identify the location where the pattern is, right? So for example, if you are using HTTPS connection, we can parse the handshake, the certificate handshake. So in that case, we can identify the subject name or the common name in the certificate. So that's one way you can, figure out where the traffic goes. In another case, in HTTP proxy, the client make a connect call, or instead of a get, a post call to the proxy first. In that case, the full URL will be part of the connect call, so we can identify the destination as well. So there are really two ways we can compile the request and your rules and report if it's allowed or not.
Yeah, that's a good, more advanced use case, utilizing the deep packet inspection that we talked about.
Yeah.
Okay, great. Okay, so I'm a user I have next-gen firewall. Can I use that for egress control? I think this is a question for Gary.
Okay. Well, yeah, next generation firewall definitely has the L7 protocol analysis capabilities. However, I think it's missing a very key visibility, which is the Kubernetes and the application running inside Kubernetes, right? So, well, not to mention those applications can come and go pretty frequently. So to this next generation firewall, because they are not deployed inside the cluster, but somewhere outside, it only sees the connections coming from either some container nodes or some egress gateway. So in most of use cases, not only you want to regulate where the traffic goes, which service can be reached or not, but also who can reach those applications, those services. You may have a public accessible services, or you may want to you have like a on-prem legacy services running inside your own cluster. So you want to have a finer control of who can reach that. Those next generation firewall doesn't give you that capability because it doesn't know the application inside the Kubernetes cluster. But our enforcer, because we are deployed next to the application, so we can have this granular control of if this particular application can reach that destination, that service or not. Another aspect of this is no matter if you're using a next generation firewall or some egress controller, egress gateway, you only use a few nodes, right? Either one firewall or few nodes, few gateways. It's actually can create a choking point. But think about our the way we implement, right? So the firewall and the segmentation are really distributed. So this give you better result, in better performance in terms of throughput, in terms of latency, right? So I guess this is really what you are trying to get in the cloud native environment. So the security should be cloud native as well. So I guess at least I can think of these two advantages.
Yeah, the flexibility and performance is an important consideration because you could scale up, scale down nodes. Then you'd have to make sure that you had enough bandwidth if you're going to put a gateway on that. Whereas in a distributed and truly cloud-native distributed environment, it doesn't matter how many nodes you scaled up or down. All of that is being done at the point where that egress is taking place.
All right, thank you guys. I think that's a good question to end on. If you guys have any additional questions or if you would like a copy of the presentation, please send us a quick email at info@newvector.com. And again, under handouts, don't forget to download the summary of comparison for egress control and the ebook on 10 steps to automate container security into your CI/CD pipeline. This webinar was recorded, so a follow-up email of the recording will be sent to you shortly after. Gary, Glen, Selvam, thank you very much for your time and the presentation. It was great. And everyone, have a wonderful day.
Yep. Thanks, everyone. Have a good
Bye,
day.
guys.
Thanks, everyone.
Thank you.
Thank you.